My name is Julia Silge, and I am a data scientist and software engineer at our studio. And in this video, we are going to use this week's Tidy Tuesday dataset on Animal Crossing. Specifically, we are going to use the part of the dataset that is about user reviews, and we are going to train a sentiment analysis model. We're going to use the words from the user reviews to the text of the user reviews to train a model about how positive or negative the review is. This is such a common real world task that people need to do, where you have some text that someone has submitted or that you get as input, and you need to understand how positive or negative the affect is there. Text is one of my big interests, so I'm really excited to be able to walk through how to be able to do this. And this is it is really exciting to be able to show how the tidymodels framework is something that is flexible. It can be applied to all kinds of different kinds of data, including text.
All right, it's Animal Crossing time. Actually, this is such a common use case for text analysis. This is like a sentiment model, basically, that we're going to be building. And this is such a common thing in the real world that we often want to do with text. We have users who have come and inputted text, and we want to know, and you know, they're associated with some grades here, like some scores, and we want to know, like, we want to be able to tell from the text what words, either from like an inferential standpoint, we want to like understand what are people talking about when they're more likely to be happy versus upset, or we want to be able to make a prediction, like when someone types in some text somewhere, we want to be able to have be able to make some prediction about whether they are more likely to be happy about their product or unhappy about their product. So let's do just a little bit of some exploratory data analysis before we get down to the modeling that we're going to build. So the model that we're going to build is we're going to take the text and we are going to predict the rating. But let's understand a little bit about the rating before we do that. So let us look at the distribution of grades here. These are the ratings that have been scraped from the review website. So that's a pretty weird distribution, right? Well, I mean, if you have experienced the internet and ratings on the internet, that does not look like a weird distribution, right? You know that either people come over here to complain and say, it's awful, Animal Crossing is the worst, or they have come over here to say, I love Animal Crossing. Animal Crossing is the best. 10 stars, 10, I love it, 10 out of 10. So from that sense, of course, from our like lived experience, we understand that this is a normal way that people use review websites. But from a modeling standpoint, if I look at this distribution, that does not look like a set of numbers that I want to model using like regression. You know, this is not this is not a distribution of just continuous variables that I think would be a good idea to try to model using regression. So I think what I'm going to do is I'm going to turn this into a classification problem. So I'm going to take, let's take like 8, 9, and 10, and let's call these the good reviews, the happy people, the people who like Animal Crossing, and let's take 7 and below, or you know, we could do 7, 8, 9. Yes, there's not that many 7s, it doesn't really matter, but let's make a cut and call one bin the good reviews, one bin the bad reviews, and let's build a model using our text to predict which reviews go in which bins. So let's do that. One thing when you are doing a text model is that it is always a good idea to look at your data. Always a good idea to like read some of them. So let's just like look at, let's say like 10 of these here, or five of these here. And so let's look at like some 5 of the high scoring ones. These are people that are so happy, very happy. That looks good. Okay, so this one, this top one, notice I am a single player that does not have to share an island. And it starts over. I am a single player that doesn't have to share an island. And we've got this expand thing at the bottom. So this one is kind of weird. It has this repeated text. It looks like there is here we've got another one. Firstly, I would like to say, and then does it repeat? Firstly, I would like to say. So we've got, doesn't look like it's the same amount of text though. And then expand. So, oh, and we have non-English in here as well. Okay, so, boy, this is some messy data. Any reviews stating there's only one island? So these are the happy people. Any reviews? I wonder if it's the same number of characters. So that would be an option. Removing the first number of characters from any review that ends in expand. Because the concern here is those words are going to get counted twice. We could distinct the words. Anyway, this is definitely, it looks like there's some problems with the scraping of the reviews here. And we ended up with a imperfect data set, as we always do here. We've got this, and this expand is a signal there. We could just throw away all the ones that ended expand. That doesn't seem like a great idea though. Yeah, so we've got, for all those people complaining, that's like a different number of characters. Or I don't know, I would have to count them to be sure. Absolutely oh no, maybe that is the same number of characters. Hard to say. Okay, all right, so we're seeing some of the problems with the data, as we often do. We can see, and that expand is definitely a signal there that we have that thing that is a problem there. So let's look at some of the unhappy ones. People who are unhappy. Less than, let's say, the really unhappy people. All right. People are unhappy about the role of multiplayer. We've got, this issue with expand again. People do not like the issues around having one island. And okay, all right. So we can see here some of the problems. I think I'm going to take out the word expand because when it's at the end, I don't think I'm going to try to do anything super fancy with removing the first number of characters because I don't know. I haven't counted them up yet manually, but it looks, is it the same or not? I'm not sure. Anyway, so this is an issue here that we have to deal with this imperfect data because we've got those words going in twice. I'm not sure how much of an effect it would have there. But let's talk about at the very least we would remove from the text the expand at the end. so that we don't have that anymore. And we can make a new column called rating, where we use case when, and when grade, let's say greater than, let's say 6, we'll call it good. And the rest of the time, we'll call it bad, like so. And let's call this reviews parsed, like so. So we will have our so we've got these bad ones here. We've parsed our text, at least that we've taken the expands out of the end. We could try to more carefully clean up this text. But the interest of moving forward, let's just go ahead. Let's do one more exploratory a bit before we move on, and let's find the words per review and see what that distribution looks like. So let's take these parsed reviews, and we're going to tokenize them on nest tokens word text, and let's count by username, and let's call that new name, that new column, total words, like so. So what this gives us is the words per everyone's review, like this. And let's look at what that distribution looks like. We can first of all just make a histogram. Like so. Okay. This is definitely strange. This is not like a natural distribution of people generating language. Here, like what I'm referring to is this edge, this cliff that it falls off and then it comes back up. Like something has happened that we have some very long reviews, right? Like, so not everything is getting cut off. We have some very long reviews, but certain reviews are getting truncated in some ways. So what this looks like to me is some kind of scraping problem with the scraping. And if I were wanting to do the best job possible with this model, my next step would be to go back to the scraping and try to figure out what the problem was and see if it could be fixed in the data generation process, because this actually looks like a pretty difficult problem to me to solve at this stage, and it would be better to generate the process, to generate the data a little better if possible. But boy, when is that not true? When is that not true that we have imperfect data, right? Like that's just life. That's all the time. So, we do the best we can with the data we have. So let's build a model. We have these limitations in the data. It has some issues, but let's see, even given that, what can we do with it? Because, that's life sometimes, isn't it? I'm waxing philosophical now about data and the real world. So the first thing we want to do as we set up our model is we want to split the data. So we're going to use the initial split function to split this data into training and testing data. So let's use a strata so that the training and testing data are split about evenly between the good and the bad ratings. So let's call this review split, like so, and we will make a training set, training review split, and a testing set, testing review split, like so. So we have training data and testing data. So we are going to build our model using the training data, and we're going to test our model using the testing data. So this is text data, right? And we're going to use this text text to predict the rating, good versus bad. Now this text data needs to be pre-processed pretty heavily to get it into a format that some kind of modeling can be done. We need to basically like get some numbers out of there. We need to convert this into some numbers that we can do math on. So we are going to use recipes for pre-processing. We're not only going to use the base recipes package, but also text recipes, which is a add-on package for text pre-processing, a package that is maintained by Emil Wiefeld. So we're going to say, we're going to declare our recipe the way we normally do, with rating is the thing we are predicting, and text are the predictors that we're using to do that. So we're going to use the data, which is the training data here, and now we're going to start adding steps to our recipe. So the first step that we're going to do is we're going to tokenize our text here. So that means take our strings and break them apart into tokens. The default tokenization is into words, but we could try some other things here. Basically the model we're going to build here is like a sort of a good first default model, but there are other things that we could do to try to make this model perform better. One of them is to, instead of tokenize into words, tokenize into n-grams, things like bigrams, trigrams. For the next thing that let's remove stop words. So these are words like is, to, of, that often are very common but don't hold a lot of meaning. And this again is like not a bad default step, but something that you could explore to see whether it helps or hurts your model. Next, we're going to do a filtering step so that we don't keep every single token that is in this data set. I'm gonna kind of filter fairly heavily so that this model runs quickly here in this demonstration. So what this means is I'm only going to keep 500 tokens after removing stop words. You could change this, and make this go up so that your vocabulary that you use in your modeling is larger, but for these purposes, let's only keep the top 500. And now I need to I need to convert these tokens into some weighting. The two most common would either be to weight by term frequency, i.e. counts or proportions like a frequency, or TF-IDF. And I'm going to use TF-IDF here because it often outperforms term frequency when it comes to modeling, predictive accuracy. And then I'm going to normalize, I'm going to center and scale all the predictors that I have after converting to TF-IDF, because the model that I want to use is sensitive to centering and scaling. So this is going to be our recipe, and I can prep the recipe to get a look at it. Prep the recipe, and let's take a look at the prepped recipe here. So remember, when we declare the recipe, we're just setting up the steps. We're not actually running it and computing what needs to happen. The prep step is when that happens. And I did it to be able to show this to you, to say we tokenize, we remove stop words, and then the centering and scaling happens on all these columns, because at the end of this, we actually have a ton of columns. Instead of having data that looks like this, at the output, we have data that looks like this, where we have many, many columns, 500 columns, because that's how many I said I want. And it has words like, columns like another, beautiful, click, change, it had 2020, has all these things in here. Okay, so that is the first thing that we needed to do to make a model. It's pre-process the data. The second thing we need to do is declare our model specification. So we are training a classification model. So let's say logistic regression, but we are going to train a classification model with lasso regularization. So let's we have to tune the penalty, the regularization penalty, because we don't know what the right penalty is, and we're going to say mixture equals 1 so that we get lasso, so we train a lasso model. We're going to set the engine equal to GlimNet here. That's what we're going to use as our computational engine for modeling. And let us set this to, let's call this lasso spec. So this is our model specification. Let's put these two things together into a workflow. A workflow helps you combine pieces of a model like a preprocessor in a recipe, review, spec, and a model review rec. That thing does not exist. Add a model, lasso spec. So this is a preprocessor and this is a model, and we put them together into a workflow. So let's call this lasso WF for lasso workflow. And then we can look and see what we have here. So we have a preprocessor and a model put together, and we can see that it's a model that is going to be tuned. So we couldn't fit this right away on one set of data. It would not know what to do. All right, so this is the model that we are going to fit to understand and be able to predict what Animal Crossing reviews are positive and what ones are negative. Okay, so we need to tune this parameter and figure out what is the right one for this set of data. And what do we need to do that? We need first a set of Lambda parameters to know what to do that. So let's make a grid, a regular grid. Let's use the penalty function. If you notice here, what we have is it's a function that just gives us here. It gives us it's a function to give us values for the amount of regularization as a tuning parameter. So and it has the right kind of transformation so that we get them spaced out right. And let's see, since I'm going to run this, let's do 30 different values. I might, when I knit this up for my blog, I might go a little bit higher, but let's, or maybe not, maybe this will turn out good. So this is going to be a grid here of things we're going to try. So there's 30 values of the regularization penalty that we're going to try here. The next thing that we need in order to tune the model parameters is some data for tuning. So let's make some resamples. So let's call this review folds. Let's do, there's like 2,200. Let's do like bootstraps. Let's make some bootstrap resamples. So we're going to take the training data and we are going to, in each little bootstrap resample, we are going to do stratified resampling so that the analysis set and the analysis set and the assessment set have about balanced. They're about balanced in the good and the bad user reviews. Okay, now I believe we have everything we need to tune a grid. Okay, so we are going to use parallel processing. So let me make sure that I set this up. Not that. No, I need to set a seed here. All right, so let's do a tuning grid here. So what do we need to do to tune? The first thing is, what model are we tuning? We are tuning that workflow that combines the recipe for pre-processing to transform the text data into its numeric representation so that we can do modeling on it. We need the resamples, the data basically that we're going to be doing the modeling, the tuning on, and we need the grid of tuning parameters to try. This is all the different values of the regularization parameter we're going to train a model at, so that we can compare across all of them and see which one works the best. And then the other thing I'm going to do here is I'm going to set some metrics instead of using the defaults. So for a classification model like this, the default metrics would be area under the curve for the ROC curve, and I still want that, and accuracy. But I would like to know if it's harder to find the good versus the bad. The good versus the bad examples, the good versus the bad ratings. So I'm setting some, instead of using the default metrics, I set some metrics here that I want to be computed during the tuning procedure, so that I can look at it afterwards and use that to understand the situation with my particular data set here. So let's while that's running, which hopefully won't take too long, let's talk about what we're going to do afterwards. So I am going to use the collect metrics function afterwards, and what that's going to allow me to do is for these three metrics that I said I wanted, they're all here in this metrics column. I'm going to be able to get those out. And we can see here I have, for every value of the regularization parameter, the penalty, I have negative predictor value, positive predictor value, and area under the curve. And so we can see it looks like negative predicted value is lower for most of these. But let's make a little visualization here. So let's put penalty on the x-axis, the mean value for that metric on the y-axis. Let's make each metric a different color. And then I think I'm going to make a line chart. And like this, and I'm going to make a separate little graph for each of these metrics. I'm going to facet wrap by metric, and those I bet I need to do scales equals free. Although actually maybe not. Those are all on. It might be easier to compare without it. I do need to do scale x log 10, because remember, penalty is transformed on the log axis. Okay, this is quite interesting. Okay, so let's think about what these shapes are telling us. So for the, let me make it a little bigger so you can see. Okay, so let's talk about area under the curve first. It goes up and then down. And so if we were picking the best model by AUC, we would pick this peak, this one here. And it looks like this peak's not at exactly the same place, but pretty, not too far, right? It's a little bit in further, but not too far. So we would pick this by ROC. But look, negative predictive value hasn't started to turn over yet. And let's see. So we could explore this further by maybe making the vocabulary bigger and seeing what happens if we try to tune the regularization parameter with a bigger vocabulary. That might be something interesting to try. This definitely points us at, so if we pick this value, that's actually down here. This helps us understand like what we're giving up by like the trade-offs kind of that we have to make here. We could pick like we will get worse, much worse, you know, positive predictive value if we try to maximize negative predictive value and so forth. So this is good. This is good to understand that we have this trade-off here between trying to detect these two different kinds of comments, these two different kinds of user reviews. So that is pretty interesting. I mean, this is really common, right? That it's difficult to choose to identify both things at the same time well. So let's take those results and let's select the best one. So here's where we have to do it, right? Like here's where we have to decide. Let's choose the best area under the curve. And let's call this best AUC, like this. So this is our best AUC. And then we can take this best AUC value, which is a value for the penalty, and we can finalize our workflow with it. So we take the workflow, which remember was tunable, and then for the second argument, we say here are the parameters, the new parameters that I want to update you with, and let's call this our final lasso, like so, and let's see what that will look like. So we're choosing our final model now. So this was our best value for the penalty, and now that penalty goes in here. Before it said tune there, and now we say, haha, I have tuned, and here is the penalty that I want to use. So now that we have done this, let's explore this final model a little bit. For example, let's look at variable importance. So the VIP package does variable importance plots and variable importance calculations. So let's take that final lasso that we just finalized. Let's fit it to the training data. And then it's a workflow, so we can pull out the final fit, the fit model from it, and then we can pipe that to the variable importance VI function from the VIP package, and we can say which lambda do we want to evaluate it at, and we want to evaluate it at the best AUC at this one here. So let's run that. So that has to fit the whole data set there. So that will give us an output, and then that's actually going to give us an output. Wait. Why not? What happened? Oh, did I not have this attached? Let's try this again. Try it again. So this will give us an output for all 500 of the tokens that we had, and also it's like great, relaxing, fantastic, daily, awesome, perfect, nice. Well, those things definitely are positive, right? So let's make a visualization where we can see the top ones. 500 things is too many things to put on a plot. If you need a takeaway from this video, that can be your takeaway. So let's take the top. Let's do 20 on each side, and the importance for the negative ones comes out as negative. So let's weight it by the absolute value of the importance. Ungroup. And now let's get some variables ready for some plotting. So first, let's say abs importance, like this. That variable, we don't need that that stuff that's at the beginning anymore. This TF-IDF text, let's get rid of that. And then let's let's reorder this so that they come out in a nice order in our plot. And now we do AES. So let's say X equals importance, Y equals variable. You can do this in the new version of ggplot, which is so nice. You don't have to be chord flipping all over the place. You can just like put the X and the Y, and it will know to say, if you want a geom call and you gave me, you know, a numeric versus a character, I will do it the right way for you, which is very nice, like so. And we are going to we need to facet that, facet wrap by sign, and though we have to do free Y. I think this works. Let's look at that. So this has to fit again. I probably should have saved that. Oh well. So that will fit, and then we'll be able to look at the variable importance here and see what are what are the most important things that push it to the negative side, to be more likely to be like a negative review? Unacceptable, worst, greedy, money, boring, second, children, frustrating, copies. So notice that a lot of these are about having having to get second copies, about having only one island per console, and like that this is unacceptable, that this is the greediness that we saw when we were reading and looking at some of those example reviews. So the copies, children, like when you have children that you're playing with, and that multiplayer experience is not great. On the positive side, it's just great and relaxing, and people are playing it daily, and it's just perfect and awesome and nice, and the music is great. And bombing, I think we saw an example of that, like the review bombing. So the people in the positive reviews are accusing the people of the negative reviews of review bombing. So that's kind of interesting to see. All right, so variable importance plot, love to see it. So interesting and great. And then finally, let's do a last fit. So what last fit does is you take your final model and you pass the split. Remember, so this actually it knows where the data is, but the data isn't even in it. So this is a kind of nice. So this is our final. It's like we're really getting to the end, right? Last fit, final underscore final. You know, we're really getting down to it here. So what last fit does is it fits to the training data and evaluates on the testing data. So it is a very nice convenience function for the thing you do when you get to the end of when you've like figured out what you want to do for your model and you want to get to the end. And it has predictions in it. It has which are on your testing data. Look how big it is. It has a final workflow that is fit. The metrics that it has here are on the testing data. So we could compare this to what we got from tuning and notice, yep, we did not overfit when we tuned. The predictions, like I just said, are, I need to spell better, are also on the testing data. We can look at this. So we've got these 700. So we've got the rating. This is the real rating, and the predicted class. So you can see, this one, the model got right. These, the model all got right. But this one, the model did not get right. And so we can look at a confusion matrix. And so first you send the confusion matrix the truth, then you send it the predicted class, like this. and we get out a little confusion matrix here where we say, and we can look, let's look at this. Okay, so the bad comments, the people where people are upset and say Animal Crossing is no good because, you know, only one island per console. We are doing better at identifying those. You can see, you know, the proportion here is better than the proportion over here. So this is related to that difference we saw before in positive predicted value and negative predicted value. The base level here was bad, because bad is first in the alphabet before good, but we could have changed that if we wanted to, if that was important to what we're doing here, whatever. So yes, so it looks like it is easier to detect the bad, the bad user comments than it is to detect the good ones. But our overall accuracy is not shabby, you know, considering that this was definitely just a use sort of sensible defaults for a text model. Things you can try to do better than this are mostly happen in your pre-processing steps. So you can do things like include not only unigrams but also bigrams, trigrams, which stop words are the best, make the most sense, are the best fit for like your data. You know, of course, making this go up would be better, especially since we were using regularization. Is this the best weighting? The different things you can do in this are what you are most likely to get the best output from. Lasso is really great for text. It is a workhorse. Other kinds of models that you could try here that you could see what might be good would be support vector machines can sometimes work well, and naive Bayes also can work well if you're interested in different kinds of machine learning models that are in the non-deep learning for text regime.
So at my house, we have 3 children and 2 Nintendo Switches. So we have for sure experienced a lot of what we saw in the output of this model. We saw that people who had positive experiences with Animal Crossing, the positive user reviews, loved, so many aspects of the gameplay. It's so delightful to use. There's so many good aspects, but it seemed like a really big driver of the negative reviews was the experience around multiplayer experience when you have more than one player on one Switch. And certainly, I would say I have experienced that as well, or we have experienced that at our house. So I hope that this was helpful, and I will see you next time.